The next topic that we're gonna study is about asymptotes. We have seen asymptote before, and we see both vertical asymptote and horizontal asymptote already when we study about the limit and continuity of the function. So let me review how to use the technique and how to determine vertical asymptote and horizontal asymptote in this video. And we're gonna apply also the technique of L'Hopital in order to find the horizontal asymptote. So the vertical asymptote is gonna be the point A such that you have limit x go to a from the right or limit x go to a from the left of fx turn out to be infinity or negative infinity. As you can see here, you have a here turn out to be the thing that call vertical asymptote. Okay, and you have fx, if you have fx in the form of the fraction px over qx, so you get two functions that you are having the quotient. So it's gonna turn out to be x equal to a is a vertical asymptote of fx if and only if you're gonna have pa not equal to 0. So you have the thing on top not equal to 0. However, the thing on the bottom turned out to be equal to 0. And it's turned out to be the condition that we are looking for getting vertical asymptote. Like we have in the next example, you have fx equal to x squared minus 4x over x squared minus x. It's going to be vertical asymptote at where? So the question asks you that. So in this case, you're going to look for the bottom guy. So the bottom guy is x squared minus x, and you're going to let the bottom guy equal to 0. So you have x times x minus 1 equal to 0. Okay, so you solve for x, you're going to get x equal to 0 or x equal to 1. So this guy is a candidate for vertical asymptote. Okay, so I'm going to just write down vertical asymptote. So it's going to be just v. Okay, so in this case, we need to check. So we need to check x squared minus 4 will not be 0. Okay, so we need to check that x squared minus 4 will not be 0 for these two x's. So you see that you have x equal to 0 or x equal to 1. So for x equal to 0, you're gonna get 0 squared minus 4 equal to minus 4, and x equal to 1, you get 1 squared minus 4 equal to negative 3. So in this case, they are not equal to 0 for both of them. So you may conclude that x equal to 0 and x equal to 1 are vertical asymptote. Okay, so this is how we conclude. So let me write it down. So you're gonna have your first step here that you solve for the denominator equal to 0. And the second step turned out to be you are checking that the numerator not equal to 0. Okay, so this is how we do this question. However, sometimes you see that if you have fx equal to x, sine x over x minus, not x minus, x over x minus pi. So this thing does not have vertical asymptote because you see that your candidate for vertical asymptote turned out to be the bottom guy. And if you have the bottom guy equal to 0, you're going to solve for x, so you're going to get two candidates, which are x equal to 0 or x equal to pi. okay? And you gonna check that you're gonna see psi 0 equal to 0 and psi pi also equal to 0. So in this case, we not get the vertical asymptote. So we get 0 over 0. Okay, so we get 0 over 0. So it's not vertical asymptote. Okay, so we get vertical asymptote. We get 0 over 0, not vertical asymptote. So we're gonna see also that if you find limit x go to 0 of psi x over x, x minus pi, this thing you see that is psi x over x, 1 over x minus pi, and you have psi x over x. Okay, so you have psi x over x. So this guy has limit equal to 1 and you plug in 0. So this guy has limit equal to 1, 1 over 0 minus pi. So this guy is negative 1 over pi. Okay, so this one has the limit equal to 1 over pi negative, and this guy not equal to positive negative infinity. So in this case, it turned out to be not a vertical asymptote. Let's do one more. If you use limit x go to pi, okay, and it's going to be psi x over x, x minus pi. So you may just multiply the bottom and try to use L'Hopital. So this guy is x squared minus pi x. And you're going to just use L'Hopital because you are having 0 over 0. So in this case, you dip psi, you get cos x, and dip x squared minus pi x, you would get 2x, okay, minus pi, okay. So you plug in, so it's going to be cos pi over 2 pi minus pi, and cos pi is negative 1, and 2 pi minus pi is pi, and this guy not equal to positive negative infinity. So you get both of them are not vertical asymptote. So we have no vertical asymptote. Okay, so this is how we determine vertical asymptote. The next thing that I'm going to teach you is going to be how to determine horizontal asymptote. Horizontal asymptote is going to be behavior at positive and negative infinity. So we are talking about behavior at positive, negative infinity. So we're going to find the limit x go to infinity of fx. And if you have limit x go to infinity of fx equal to b, you're gonna see that you're gonna have the first picture, okay? So it's turned out to be horizontal asymptote, and you have limit x go to negative infinity equal to b. So in this case here, so you see that you get a horizontal asymptote as well. So you're gonna have at most two horizontal asymptote. Okay, so the thing that you may see is going to be we have at most two horizontal asymptote for each function. Why not? Why don't we have more? Because it's going to be just these two limit. Okay, so it's going to be just these two limit in order to determine horizontal asymptote. So we're not going to have more than two horizontal asymptote. So basically, if the question asks you to find horizontal asymptote for the function, basically this one is equivalent to say that, so this one is going to be just find limit x go to positive infinity of fx and limit x go to negative infinity of fx to see if they exist. If they exist, you're going to get two horizontal asymptotes. If you just have one exist, it's going to turn out to be just one horizontal asymptote. If both of them does not exist, so it's going to be no horizontal asymptote. That's all. The idea is very simple. So in this case, you see that this one, if I graph y equal to arc tan x, okay, I have done this one many times. So in this case, if you graph this one, you're gonna see that it's gonna be an S-shaped curve, okay, and you're gonna get this one and this one, okay, so it's gonna look like an S like this, and you see that these two lines are y equal to pi over 2 and y equal to negative pi over 2. Okay, so you see that you have limit x go to positive infinity of arc tan x equal to pi over 2, and you have limit x go to negative infinity of arc tan x equal to negative pi over 2. So you have two direction in this case. So you have here, and you're gonna have the yellow guy up here. Okay, so in this case, you're gonna say that you're gonna have y equal to pi over 2 and y equal to negative pi over 2 are horizontal asymptote. Okay, so in this case, you are having two horizontal asymptotes, and they are y equal to pi over 2, and they are y equal to negative pi over 2. So you have two lines. The next one, so for B, like I said, we're gonna just find limit x go to positive infinity and negative infinity of this function. So in this case, you're gonna find limit x go to infinity of this quotient. So it's gonna be limit x go to infinity of x squared minus 4x minus 2x squared. And the way to do this example will be you're not gonna simplify this one, you're gonna pull out the highest degree. So it's gonna be 1 minus 4 over x squared, and you're gonna pull out x squared, so you get 1 over x, okay? So you get 1 over x minus 2, okay? So you simplify this one by canceling x squared, and you're gonna find limit, let do not use limit yet. So you're gonna find limit x go to infinity of x squared minus 4 over x minus 2x squared. So it's gonna be equal to, so you see that it's gonna be limit x go to infinity of 1 minus 4 over x squared, 1 over x minus 2. So this guy will be negative 1/2 because you get 4 over x squared go to 0 and 1 over x go to 0. Okay. Another limit that you're gonna find will be limit x go to negative infinity. So you get x squared minus 4, x minus 2x squared, okay? And this guy will be limit x go to negative infinity, and you have 1 minus 4 over x squared, and you have 1 over x minus 2. So in this case, you're gonna get also that this limit turned out to be 0 and 0. So the limit turned out to be y equal to negative 1/2. Okay, so what does it mean to have these two limits? It means that you have only y equal to negative 1/2 is the only horizontal asymptote. Okay, and you see that the function behave in this way, so you get this one and this one, so you have y equal to y and x, so you get y equal to 1/2, which is this horizontal line, so you have y equal to negative 1/2, sorry. And you see the graph of the function tend to, okay, so it's gonna look like this when x go to positive infinity and when x go to negative infinity. Okay, so this is the thing that we have, and it's gonna be tending both sides, so it's gonna be on the positive side and on the negative side. Okay, so this is how we determine horizontal asymptote. So we have only one horizontal asymptote for this first example. The next one is going to be, you're going to have fx equal to x minus e to the x. So for this guy, you have x over e to the 2x. Okay, so you're going to find this limit by using L'Hopital. So you need limit x go to infinity of x over e to the 2x. So you get L'Hopital infinity over infinity that you will apply L'Hopital. So it's going to be limit x go to infinity of 1 over e to the 2x times 2. So it's going to be 1 over infinity, and this guy turned out to be 0. Another limit that you have to find is going to be limit x go to negative infinity of x over e to the 2x. So in this case, you see that you're not going to get infinity over infinity. You're going to get negative infinity on top, and you're going to get e to the negative infinity, 2 times infinity, like this. So in this case, you're gonna get negative infinity multiplied with e to the 2 times infinity. Okay, so it's turned out to be just negative infinity, and this term, okay, turned out to be infinity. So in this case, it's gonna turn out to be infinity multiplied with infinity. Let me write this guy as a green color. So in this case, you're gonna get the total. It's not gonna be L'Hopital. This thing is gonna turn out to be equal to infinity. Okay, so we gonna be that this guy is gonna be, we have y equal to 0 is the only horizontal asymptote. Okay, and if you draw the graph, it's going to be different from the previous question. So in this case, you're going to have yx. Okay, so you're going to have y equal to 0, which is this horizontal line. Okay, so you have y equal to 0, which is this guy. And you see that when x go to negative infinity, it's going to turn out to be, it's going to be negative infinity here because the negative side. So in this case, you're going to go down, okay, to negative infinity. And for this one, it's going to go to 0. Okay, so it's going to go to 0. So the picture turned out to be this one, and you have y equal to 0 is playing the role of horizontal asymptote. Okay. The next one, you have fx equal to square root of x squared plus 3 over 2x minus 1. So in this case, you're gonna simplify this one a little bit before taking the limit. So you see that this guy can be written as x squared, and you pull out, so you get 1 over 3x squared. Okay, and this guy, you have x outside, and you have 2 plus 1 over x, not plus, so it's going to be minus sign. And you see that on top it's going to be square root x squared, square root 1 plus 3 over x squared. Okay, and you have x 2 minus 1 over x. Okay, and I told you before that square root x squared is equal to absolute value of x. So this guy will be absolute value of x square root 1 plus 3 over x squared. Okay, and you have x times 2 minus 1 over x. Okay. Okay. So in this case, we're gonna simplify, and we're gonna do anything further when we taking the limit. So in this x go to infinity, so you are taking limit x go to infinity. So you are taking limit x go to infinity of absolute x plus 1 over 3 over x squared. Okay, and you have on the bottom, you have x, and you have 2 minus 1 over x. Because you are having x go to infinity, you see that this guy, you have x positive. Okay, so it's going to be x equal to 1 million, 2 million. So in this case, absolute value of x turned out to be just x itself. So this guy turned out to be just x. So this one will be limit x go to infinity of x square root 1 plus 3 over x squared, and you have x 2 minus 1 over x. Okay, and you're gonna have x and x. Okay, and you have x go to infinity, so this guy turned out to be 0 and 0. So the limit turned out to be positive 1/2. Okay, so you have the limit equal to 1/2 in the first case. And we're gonna find limit x go to negative infinity of the same guy. So it's gonna be absolute x square root 1 plus 3 over x squared. Okay, and you have on the bottom x 2 minus 1 over x. And you have x go to negative infinity. So in this case, like I told you, so you have x go to negative infinity, it's gonna be an effect on, we're gonna have an effect on absolute x. So in this case, x go to negative infinity, the emphasizing thing is gonna turn out to be the negative side here. So you get x negative. And when you get x negative, you're gonna have absolute value of x turn out to be minus x. So you get limit x go to negative infinity of negative x square root 1 plus 3 over x squared over x 2 minus 1 over x. And this guy, you get to cancel x and x like this. So it's turned out to be, so this guy gonna go to 0, this guy gonna go to 0. So it's turned out to be negative 1/2. Okay, so you have limit equal to 1/2 and negative 1/2 respectively. So you're gonna conclude for this example that you have two horizontal asymptotes. So you have y equal to 1/2 and y equal to negative 1/2 horizontal asymptote. Okay, and if you take a look at the graph, so if you graph this one out, you're gonna see that you're gonna have y equal to 1/2, which is I'm gonna draw with the green color. So you have this guy, okay, so y equal to 1/2, and you have y equal to negative 1/2, okay, to be your two horizontal asymptote. And you see that x go to positive infinity, it's gonna go to the green one, and you have x go to negative infinity, it's gonna go to the pink one. Okay, so this one is the direction that we can see from computing the limit also. Okay, so this one is the yellow and the green respectively. Okay, so they are about the what is called vertical asymptote and horizontal asymptote. Now we're gonna talk about the shape of the graph. So when we have the thing that we have been studying is going to be about decreasing, increasing, and concavity. Concavity, you have two kinds of concavity. They are concavity upward and they are concavity downward. So for increasing, it's going to be increasing. However, it's going to be increasing together with concavity. If you have increasing concave up, okay, so the picture turned out to be this one, and you see that you have the tangent line, which is this line, and it's going to turn out to be the graph is above the tangent line. The picture of increasing and concave up will look like this one. And if you consider the sine of f prime and sine of f double prime, you have f prime, okay, I'm going to write f prime, and I'm going to write f double prime below the x-axis. So you have the sine of a prime turn out to be in this case because you are having increasing. It's going to turn out to be the sine of a prime is positive, and the sine of a double prime because it's concave up is going to turn out to be positive. So if you have positive red and positive green in this case, it's going to be this picture. Okay, so you need to memorize the shape of the graph. And you have increasing concave down. Increasing is going to look like this one. It's going to be increasing. And concave down is mean that the graph is below the tangent line. So in this case, it's going to be positive for f prime. And you have negative for f double prime. Okay. And the next one, you have decreasing, okay, decreasing, but the graph is above the tangent line. So it's in the case that you have decreasing concave up. So in this case, the sine of f prime turned out to be negative due to decreasing, and the sine of f double prime turned out to be positive for the case that you have concave upward. The last one, okay, is going to be just decreasing and concave down. So you see that the sine of f turned out to be, the sine of f prime turned out to be negative, and the sine of f double prime also negative. So it's going to be four kind because, or not four kind, four cases because you have two choices for each. So you have increasing, decreasing, concave up, concave down. So you match these two guys, you're gonna get four cases, and the four cases distinguish in the following shape. So you have increasing concave up, increasing concave down, the graph is below the tangent line, decreasing concave up, the graph is above the tangent line, but the graph is going down. And you have decreasing concave down, the graph is, this one is above, right? This one is above the tangent line, but the graph is going down. And for the last one, the graph is below the tangent line, and you see that the graph is going down. Okay, so this one is the shape of the graph that you're gonna determine from the sign of f prime and f double prime respectively. So this thing is gonna be useful in order to shape the graph. Let's do this example. We're gonna sketch a smooth connected curve y equal to fx. Okay, so you're gonna shape this guy, and you're gonna know some point. You know f negative 2 equal to 8, f prime 2 equal to f prime negative 2 equal to 0. So we can remark that this guy are critical number. Okay, so these two guys are critical number. And you have f0 equal to 4, f2 equal to 0, f prime x less than 0 for x between negative 2 and 2. So this one will give you the sign of f prime. Okay, and you have f prime positive, f prime negative. Okay, and the next thing that you know is going to be the sign of f double prime. So you have f double prime is negative when x less than 0, and you have f double prime is positive when x positive. Okay, so in this case, you're gonna graph this one. Okay, for this example, so you see that you have y, you have x, and you have 4, you have 8. Okay, and you have f negative 2. So let me scale this one a little bit. So it's going to be negative 2. Okay, negative 1, 0, 1, 2. Okay, let's do 3 also. Okay, so in this case, you're gonna put the sign of f prime. Okay, so you put the sign of f prime, and you're going to put the sign of f double prime. Okay, so for the sign of f prime, you see that it's going to be positive when absolute x is more than 2. Absolute x is more than 2, you know that this guy is about x more than 2 or x less than negative 2. So in this case, it's going to be positive for this interval and positive for this interval, and it will be negative for the rest. So you have negative. Okay, and for the second derivative, you see that it's going to be negative when x is negative. So you see that it's going to be negative for the whole interval here, and you have positive for the x positive. So you're going to have positive in this interval. So you see that we be able to separate this one into how many? So you see that we have these pieces, and we have negative, negative, the same thing, okay? And we have negative, positive until here, and we have positive, positive. So the thing that I use to separate my interval turned out to be the sign of f prime and the sign of f double prime. You see that this one is positive together with negative, and here it's going to be negative, negative, and negative, positive, and positive, positive. And you're gonna compare with the thing that we have on the previous page about the shape of the graph. So here you have the side. Okay, so here you have the side, and you're gonna have the shape. Okay, so you're gonna have the shape of the graph. This one we're gonna read it as uh, increasing concave down. Okay, increasing concave down, increasing concave down. So you draw something like this. Okay, so we're gonna draw this shape in this interval, and you have decreasing concave down. Decreasing concave down, you get this picture. And you have decreasing concave up, you get this picture. And this one is increasing concave up, so you get this picture. And you're gonna plot some point that you know for value. So let me plot f negative 2 equal to 8. So we know that it's gonna pass here. F 0 equal to 4, it's gonna pass here. F 2 equal to 0, if 2 equal to 0, so it's going to pass here. And you also know that it's going to be horizontal tangent line f prime 2 equal to 0 and f prime negative 2 equal to 0. So in this case, you know that f prime 2 equal to 0, so it's gonna should look like this because of the shape of the graph. So it's gonna give you this one. Okay, so you see that the shape is like this, and you're gonna draw the graph, okay, in this shape until here. And you see that this one gonna continue like this, and finally you're gonna have something like this. Okay, so this one is the shape of the graph that you're looking for. So you see that you combine the shape in each interval together with the point that the graph is passing through. And you try to draw the horizontal asymptote. Okay, so you see you have asymptote. Let me use this color. So you see that you have horizontal asymptote, okay, at negative 2 and 2. So this one will be your horizontal asymptote that I indicate. And you see that this guy turned out to be maximum and minimum respectively in this one. Okay, so you have local max at negative 2 and local min at 2. Okay, so this is the whole thing. In the next lecture, I'm gonna teach you how to graph the function. We're gonna have to find increasing, decreasing, concave up, concave down by finding the first and the second derivative by ourselves, and we're gonna have gathering information enough in order to sketch the graph of the given function. Okay, that is the topic of the curve sketching. Here is going to be just like a first example, the basic idea. Okay, so I think I'm gonna stop here, and that's gonna be all for this lecture, and the next one will be more fun. Okay.